Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to study about elemental analysis. So this elemental analysis is a broad topic of analytical techniques. In this particular lecture we will going to understand that what is elemental analysis. We will also understand and learn about different types of elemental analysis, and we will going to see the applications of an elemental analysis in different field of industries. So let's get started with the topic and let's see what is elemental analysis and where it is applied. So basically in this particular lecture we will going to study about elemental analysis, and further we will going to understand that what is the applications of elemental analysis and where this elemental analysis basically works. And like we all know that different types of techniques are used to determine the purity of any compounds or purity of any substances. So how this elemental analysis helps in knowing the purity of any substance, and how it is used in different fields, for example in food industries, in environmental sciences. So how it is used. So if we see the definition that what is elemental analysis actually is, so it is defined as the determination of the amount of an element that is given in a sample. Usually we talk about the weight percent. Okay, so there are different elements in many of different samples, because every sample have different elements. Exactly. So there is a number of techniques, the more or less suitable for the analysis of element of sample of interest. For example, there are some basic techniques that are used are X-rays, fluorescence, absorption atomic spectroscopy, inductively coupled plasma, ICP optical emission spectroscopy. So all these techniques we have studied so far, isn't it? We have studied about X-ray fluorescence, we have studied about absorption atomic spectroscopy, we have studied about ICP, that is inductively coupled plasma. So all these techniques are widely used in laboratories for analysis of any sample of the interest. If you want to know for example, if in a particular sample, if you want to determine any element, or you can say any element of your interest, okay, so with the help of elemental analysis you can able to do that. Okay, so this is a very important as well as very useful techniques where you want to know the sample of the interest. So the elements here, one thing I am using again and again, that one word, that is elements. Okay, so elements, they are very critical for the quality as well as whenever the safety of any material is concerned, and it is present in a very low concentration. If you talk about the elements, so they are present in a very low concentration, so it requires a very highly sensitive instrumentation for the determination of elemental composition. So what are the different types of instrumentations? For example, X-ray, absorption, inductive coupled, etc. Now let us understand what is elemental analysis in broad category, like in determining the elemental composition of metal. So whenever you want to determine the composition of material, means if you want to determine the elements, that elemental composition that is present in any matter, whether it's a qualitative or in a quantitative. Okay, so with the help of this elemental analysis, you can analyze both the qualitative as well as quantitative elemental composition of the material. So it is not only concerned with the quality, it is also concerned with the quantity. Now comes CHNX. Okay, so CHNX is a combustion analysis for verification of compound and identity. So where you want to verify where of the particular compound identity, so you can use elemental analysis. Then in different elements other techniques are used. Okay, so now comes the most important thing, that how this elemental analysis is applied, means what are the different field where this elemental analysis is applied. So the first is material sciences, second is geosciences, then is your environmental sciences, in industries, in forensic. So we will going to understand each field in detail. Let's talk about the first one, that is material sciences. So elemental science is very important when you, where you want to know the meteorology, glass ceramics, cement, superconductors, microelectronics. Okay, because whenever you want to know the composition, where you want to know the sampling of these cements or these superconductors, so their elemental analysis has a huge application. Okay, now how it is useful in environment geosciences. So for example, geochemistry, mineralogy, geochronology. So everywhere it is not only concerned with any particular industries, no, it is concerned with every industries, whether it's a geographical analysis, or it is related to any biological analysis. Everywhere elemental analysis play a very vital role. Okay, now comes the environmental sciences. Okay, so environmental sciences also, whenever you want to identify the amount of different types of pollutant that is present, so you can use environmental analysis in determining that. Then comes the biological system and medicines. So it has a huge application in pharmaceutical industries also, as it is used to identify different types of samples, different types of compounds that are used in the production of drugs, or you can simply say it is used in the manufacturing, or not manufacturing, in analysis, the drug discovery. So it has a huge application in pharmaceutical as well. Now, for example, in quality controls, QC. So how the establishment established that produce material confirm in it in terms of composition and purity. So there this type of sciences can be used. Then if you want to know the processing control, food safety, including packaging. So in fact, in packaging also it has a huge demand. So it can be widely used in different packaging industries also, where the particular item is being packed. So it has a huge application there also. Now comes the forensic. So we all know that this forensic sciences is related to the science, or it is a field of science that involves in giving the justice to a particular person. Okay, to or not to a to a victim, right? So how it is used in forensic sciences? So in forensic sciences, it determine the composition of soil. It helps in the determination of fiber, plastic, paint, etc. to establish the origin. Because we all know that the soil or the paint or anything that is there at the at the crime scene act as a it act as a evidence. So in determining the evidences, this elemental analysis play a very important role. Okay, so these are the applications of elemental analysis. Now if you see, this elemental analysis basically are of two types. The first one is destructive and second one is your non-destructive techniques. So that under the destructive techniques there are ICP-MS, AAS, IC. Okay, in this non-destructive techniques, XRF, INA, HRCS, AAS. So all these techniques, for example, AAS means atomic absorption spectroscopy. XRS is a X-ray fluorescence spectroscopy. So we all have X-ray fluorescence spectroscopy. So all these techniques, whether are destructive or non-destructive, we have already discussed in our previous lecture. So you can go to that lecture and can get updated. Okay, now let us understand one thing, that is the elemental analysis overview. Okay, so if you are talking a method overview, so basically there are two methods. First is the if we saw the first method, that not two method, it's the first is the classical method. So classical methods are of two types. The first one is the qualitative and organic analysis. Okay, second is a quantitative, that is gravitometry, tetrometry, chlorometry. So what are the different types of instrument used here? Spectroscopy, for example, atomic absorption spectroscopy, mass spectroscopy. Okay, so these are the instrument where you want to analyze the trace analysis that is present in a solution. So every method or every if you want to analyze anything, so every थिंक मतलब हर एक चीज़ को एनालाइज करने के लिए एक डिफरेंट इंस्ट्रूमेंट होता है. फॉर एग्जांपल, इफ़ यू वांट टू एनालाइज एनी सॉलिड मटेरियल, देन यू कैन यूज़ एक्सरे और मास स्पेक्ट्रोस्कोपी. So now let us understand one thing here, students, that how this procedure of this analysis take place, means how this elemental analysis is done, or what is the procedure, or what are the different processes that are involved in elemental analysis. So the basic step of an elemental analysis is first is your. Okay, so by the time, let me write a heading for you so you can note it down somewhere. So I'm just talking about the basic steps of elemental analysis, that is EA. Okay, I think there's some space issue. IA. So what are the basic steps of EA? So if we the first step is you have to choose the sample. Okay, choose a method to use for the samples. First of all, you have to choose method. Okay, that by which method you will use to identify any sample, whether it's a destructive method or a non-destructive method. Okay, whether in you are using atomic absorption spectroscopy, or whether you want to use X-ray fluorescence spectroscopy, or you want to use any inductive couple spectroscopy. So after that, using the chosen method, let's say you have chosen X-ray fluorescence spectroscopy. Now obtain the percent of the composition. Now what you have to do, you have to obtain the percent of the composition. After that, using the percent of the composition, you calculate the empirical formula or molecular formula, or whichever is relevant for that particular method. So by this you can analyze the element. These are the basic steps that are used in elemental analysis. Okay, now let's quickly see this as an analytical process, general consideration steps. For example, the first one, you have to select the method that I have just told you. For solid state method, or if you want to analyze any liquid state. So depending whether it's a solid or whether you want to analyze any liquid, then you have to define the sample. Okay, then the processing of sample to take place. I'm just talking about the liquid one, solid state method first. Then after that, process sample it, the first is the eliminate the any interference. If there is any foreign thing, you have to eliminate that. Then you have to measure the x that I have told you. Then you have to calculate the result, and you have to determine the errors, because there are different types of errors that we will going to understand in the next part of the in the later of this slides. So this is how the solid state method take place. Already I have told you, you have to choose the method to use for the sample. Then you have to choose the method, obtain the percent composition. After that, using the percent composition like this, you have to calculate the result with the help of any empirical formula or molecular formula, or whichever is relevant for the method. Okay, similar case is with the liquid state also. You have to define or choose the sample, then you have to process the sample. Okay, you have to see, since it's a liquid, so you have to see whether it's a soluble. If it's a soluble, then you have to measure the property. If it is not soluble, then you have to do the chemical dissolution. Okay, both the way you have to measure the property. Okay, if the property is measurable, okay, so you have to follow all these things, that is eliminate the interference, measure the x, calculate the result, determine the error. But if the property, let's say the sample is not measurable, then you have to change the chemical form. So chemical form you have to change, that is you have to get back to the solid one. Okay, so this is the general output. Now comes the method of selection. So method selection, that is consideration. So we have already discussed here that there are two types of elemental analysis, that is the destructive techniques and the non-destructive techniques. So if we talk about the destructive method of analysis, so the destructive method of analysis is the X-ray fluorescence emission, and atomic absorption, and is also is one of the most important thing. So you can take a screenshot of the methods that are under the destructive and that are under the non-destructive. Non-destructive, we have discussed under the destructive: atomic absorption, volumetric, combustion analysis. Okay, so accepted annihilate consideration and performance characteristic method must be watched. Okay, now comes the qualitative analysis principle. Again the same thing that we have just discussed here, so it's again a revision of that what are the qualitative analysis principle. Okay, so if you talk about the principle, then you have to firstly define the sample amount. Means you have to define the sample amount, whether it's in the form of a quantitative or in the form of a non-quantitative. Then you have to measure the quantity proportional to the annihilate solution concentration. After that, you have to measure the property that must vary in defined way, that is calibration with a known standard necessary, and second is with the interference that must be known, and if possible it could be eliminated. So here the two things is to be understood, that is what is accuracy and what is precision, because this is a very important, because in examination also, in interviews also, they can ask you what do you understand by accuracy and what do you understand by perception. So accuracy, it is a proximity of measurement measured value to accepted, that is you can say accuracy is a true value. Okay, it must be determined. But if you see the precision, So precision is very close to the true value, must be defined and reported. So accuracy, it is a true value, and precision, it is the value that is very close to the measured value. Okay, or you can say it must be defined and reported, and accuracy, of course, it must be determined. Now, let us understand the performance characteristics of quantitative analysis method. So, the first one is accuracy. The method should be very accurate. Okay, means whenever you are using any method, let's say you are using X-ray method or fluorescence or atomic absorption, so all those method must be very accurate. Okay, the precision, accuracy, under accuracy it should be bias recovery means it should be recover. Okay, because we have studied different techniques where the samples could be recovered after the method took place, after the process ends. Okay, then the detective reproducibility, it should be a good means it gives a very good output or yield, and it could be used in a repeat way, you can say repeatably. And the detection capability, it should be very good, means it could also could detect a very a sample that is that are very sensitive in nature. It can detect the limit of detection. It can limit the quantitation of the sample. Then selectivity and specificity, it should be very specific, it should select a wide range of the sample. It should be very linearity in nature. Working range should be good. Okay, so these are certain characteristic that analytical method should possess. Okay, so we have just talked about the errors. So basically there are different types of error, like systematic error and the randoms error. So what do you understand by this systematic errors and the random errors? So the systematic errors are the sources, like the errors that occurs within a system. Okay, within a instrument, means if there is any error in the instrumentation part. Okay, if there any part in the instrumentation, that is for example detector, if the detector is showing the error, so that comes under the systematic error. If the method that you have used is having certain types of error, so again it is a systematic error. Again, personal error, a person who is performing the experiment, and if he or she mishandle the process, so there is a systematic error. So it can be discovered, and it could be corrected also. It is nothing that it could not be corrected, it could be corrected. Standard reference materials, blanks, control examples, skyped samples, so all these thing can be can be recovered, and it can be corrected. Handled error by proper, so it is always recommended, so to avoid these huge range of error, so the material should be handled, or the process should be handled in a very aseptic environment, as well as a material should be handled in a close or very close, you can only say the close observation. So these are the systematic error. And what is random error? So random error always present, and it cannot be corrected. Okay, so it is always there, you cannot correct them. They are consequence of uncertainty of certainty of the certainty of the measurements. For example, electrical noises from the instrument, you can't correct that noise, you can't stop that noise that comes from any instrument. Okay, so it may causes the fluctuation in reading. Then there are uncertainties in the experiment of mass and volume. This is again one thing that you cannot correct them. Okay, then there is a ultimate limitation in quantities. It must be aware of the error and deal with it, repeated measurement. So whenever you find any error and you are knowing that you came across that this error is coming from that side, so you must take some primitive steps before using that techniques. Okay, you should take certain types of steps to avoid those errors. Okay, so this is the experimental errors. So we have just talked about the different types of analysis. So one thing I would like to explain you here, that what is inductively coupled plasma. Okay, so inductively coupled plasma, it combines with a high temperature inductivity coupled plasma source with a mass spectrometer. Okay, so this is one thing I have to explain you. Okay, now this is the end of the lecture. Now let's discuss some important question from your interview point of view also. So in exams also, or in the interviews also, they can ask you that what are the other organic mass spectrometry methods. So basically we have just understood about the destructive and the non-destructive one. So the question says that, I'm just writing the question, you can note it down somewhere. The question says that what are the other inorganic mass spectrometry method. Okay, so for example, there is a spark source spectrometry is one of the method. Second is a laser ionization mass spectrometry. Then there is a thermal ionization mass spectrometry. There is a glow discharge mass spectroscopy. So these are the other inorganic mass spectrometry method that are used. Okay, now the second question can be asked in the interviews, that what is the ICP-MS method. So ICP-MS, it can be coupled with a variety of separation techniques. So we have already discussed about the liquid chromatography, in which we have studied about the HPLC. We have studied about the capillary electrophoresis. So ICP-MS is the coupled, you can say, can be coupled with a variety of separation techniques like liquid chromatography or the capillary electrophoresis. So we have discussed this. So now let us understand our next question that can be asked in the interview. So in interview point of view, they can ask you what you understand by elemental analysis. Okay, so you must be aware of the elemental analysis and how it is used in different industries. So this question in examination is widely asked or frequently asked, you can say. And that we have already discussed that it is a method that is used for the analysis of qualitative as well as quantitative. So you must be knowing that. They can also ask you what are the different types of elemental analysis. So we have already discussed about the elemental analysis type, that is the destructive method and the non-destructive method. So you must be understanding all these questions in detail. So any other question I would like to explain here. So the other question it can asked in examination, they can ask you what is the separate specification and speciation analysis. So you can go through this question. And since I am not again giving lectures on that instrumental and analytical method, because already we have discussed all in our previous lectures, so you can go and refer to that lectures. And we have already discussed about the principle, so in examination they can also ask you about the principle as well, so you must be knowing the principle of the all the techniques. Okay, so that brings to the end of the lecture, student. If you have any doubt, any queries related to the lecture or related to the questions that we have discussed, you can simply leave the queries in the comment section below. In the next lecture I'll be answering the queries. Thank you for watching. Please do like, share and subscribe. Thank you.